All right, our mission for today is to graph systems of linear inequalities. If you pay attention to the word inequality, prefix in means not equal. So inequalities are different from equations. So if you run into a test question that says write an inequality to model this situation, I don't want to see equal signs in your equation. I want to see inequality symbols. Less than, greater than, less than or equal to, greater than or equal to. So you're copying your vocab. System of linear inequalities is much like a system of equations. There's just more than one. A solution to a linear system isn't going to be just one point of intersection today. It's going to be the solution region that's common to both graphs. Basically, where your two shaded regions overlap today is where your answer is going to be. And when you graph a system of linear inequalities, it's made up of the lines and the solution regions that overlap. So let's do it. We have two steps. The first thing I always do is I graph the inequality in the system, almost paying zero attention to the symbol that's in there. And I just treat it like it's y equals mx plus b. And then I go back and I fix it. So I graph the linear inequality that's there. And then we can use our colored pencils to distinguish the different solution regions. In step 2, you're basically going to identify the region that's in common to both graphs. How will you be able to tell? Well, if you're using colored pencil, it'll be the place where both colors are present. If you're really not sure, how can you check? Grab a test point like we did in class a few moments ago when I went over the homework. Grab the origin, grab a point in your solution region, check it. It'll work this time in both inequalities. It has to again generate two true statements. Let's do it. So the first thing I'm going to go ahead and do is graph y equals 2x plus 1 and y equals negative x minus 3. Almost paying zero attention to the symbol in between. So I have y equals 2x plus 1. I'm going to graph that first. So I go up 1, and then that's going to have a slope of positive 2. So I go up 2 over 1, down 2 over 1 to get the pattern. And I say almost paying zero attention to the symbol in between. Well, if you take a look at this particular problem, I do have a less than symbol. So you have to ask yourself, solid or dashed? And it sounds like you did pretty well on the homework. You guys know that this would be a dashed line. And then I grab my colored pencil. I'm going to grab my highlighter because it's a little friendlier. Shading on the smartboard isn't, I don't know, they need to fine-tune this tool a little bit. But I need to shade now y values that are less than 2x plus 1. That's what that symbol means in words. So if I'm thinking about values that are less than this line, what I'm going to do is I'm going to look at the y-axis and identify the part that is less than that line. The y values less than that line are below the blue dashed line, so I shade below. If you're not sure, you can test. I would test the origin. I've said that a couple times already. If I test the origin, 0 is less than 2 times 0 plus 1. 0 is less than 1, so I should have shaded where the origin was, and I did. Are there questions about how or why I shaded or drew dashed or got that particular line? No? Now we get to do it again. We're going to do, I'll do it in a different color this time. Y is less than or equal to negative x minus 3. So I'm going to go down 3 for my y-intercept, and I'm going to put a dot there. And then this slope, the slope of this line is a negative 1. And then I notice that I have a less than or equal to symbol. And in this case, the line actually is part of the solution. to this particular system. Oh, I went down 4. Thanks, Brian. It's like, why doesn't it fit? There we go. And then we go down 1 over 1. That looks better. And I did it as a solid line. Now this is less than or equal to. So I look at the red line and I pick out the y-axis in reference to this line. And since it's less than, I want to shade the y-axis that's below that red line. So I'm going to shade everything underneath. Again, you know, if you wanted to check yourself, you could grab a test point. This actually doesn't look all that nice. When you highlight, I thought the yellow would come through a little bit, but it doesn't. Grabbing a test point to make sure I shaded the green spot correctly. The origin, if I plug it in, 0 is not less than -3. The origin doesn't work for that particular inequality, so I can't shade there. And that's why I shaded below the red line. Ultimately, my solution region, you want to make that very clear to me. It's right there. And we just identified the region that was common to both graphs. We could check using a test point. So at this point in time, you know, I can see that the point, grab something easy for yourself, maybe even on the axis. The point 0, -4, looked like it was common to both regions. So I'm going to grab a test point and just check it. So here's me checking. I grabbed a point just to make sure I shaded in the right spot. So I'm going to check and make sure that 4 is indeed less than 2 times 0 plus 1. And the last time I checked, sorry, it's supposed to be -4. -4 is less than 2 times 0 plus 1. The last time I checked, -4 is totally less than 1, so that worked. 0, 4 wouldn't have worked. So I know I'm on the right track. And then I'm going to check 0, -4 in the other inequality. So I'll take -4, make that less than or equal to -0 minus 3. And then I have -4. And I'm checking to see if it's less than or equal to -3. And it's definitely on the less than end of the spectrum. So my test point works, which means I shaded in the correct region. So there is a way to check these, is what I'm trying to tell you. Questions about that? In example 2, we have y is less than or equal to 4, and y is greater than the absolute value of x minus 2 plus 1. I would like you to take a moment now and graph those lines for me. Well, graph the line and the V-shaped absolute value graph. Let's see what you remember from getting your test back just a few moments ago. So take a moment. I just want you to get the lines down, and then we'll talk about how to shade. Okay, so as I walked around, everybody had their V-shaped graph in their line. Good job. I actually started to just kind of check where I was going to shade. I want to shade my y values that are below or less than or equal to 4. So I would grab my highlighter and shade below that line. And then I also need to shade y is greater than the absolute value graph, greater than the V-shaped graph. That naturally tells me above just by looking at the symbols. But if you're not a fan of looking at the symbol and saying it in words and figuring out do you shade above or below, your default method is to check with the test point. So I checked 2, 2, because it was right in that V there. On the interior, if you remember from geometry, that's the word. And that tells me that I just need to shade above or sort of in the mouth of this V-shaped graph. So ultimately, my solution region is a triangle. Again, we shade the region that was common to both graphs. Questions about that? we got one problem left. Word problem. Word up. We might get to building the equations today, but I have a feeling that you folks are going to actually need to graph and shade a little bit on your own as your conclusion. So in example 3, we want to solve this multi-step problem. We're selling pizzas to raise money for a school field trip. We have cheese pizzas that cost $8 and pepperoni pizzas that cost $9. And you can kind of see that they've already defined for us what our X and Y values are, right? It's going to be the number of cheese pizzas and the number of pepperoni pizzas. And we can see that on the, sorry about that, the X and Y axis. Cheese pizzas is X, pepperoni pizzas is Y. And you need to sell at least 2 of each pizza type. And you want to sell at least $150 worth of pizzas. I need to write and graph a system of linear inequalities that describes the information given above. Can anybody give me one equation? One inequality, I should say? Kind of like 55 in last night's homework with the acoustic guitars and the electric guitars. Go ahead, Jackie. Excellent. And then we have that last sentence there. It says you need to sell at least 2 of each pizza type. Oh, hi. I was recording this just for you, Claire. You need to sell at least 2 of each pizza type. How do you write that as an inequality? Go ahead, Will. Yeah. Good. Uh-huh. Good. That's it. So this time around we're shading 3. And how did you get that? Well, because I have a feeling maybe some of your classmates were. Yeah. Anytime it's a least, we're talking greater than or equal to. Because, you know, it's going to be obviously more profitable to sell more than that. So that would be great. But we don't want to sell, you don't want to sell no pizzas. That's not much of a fundraiser, is it? All right, so to wrap up today, to make sure you understand the lesson, I'd like you to graph these and shade them. Graph these and shade them. Keep in mind that X equals a number is a vertical line, Y equals a number is a horizontal line. This guy you're going to have to transfer into Y equals MX plus B form to graph him, kind of like you did the other day. So I'll give you a minute to wrap that up and we'll talk about our answers. Or the bell could ring. This example is also in your book. I'll post it as a complete response as a PDF file on Blackboard. You grabbed graph paper when you walked in. Of course, there's some graphing tonight. And if you could return your colored pencils, that would be awesome. Hey, have a great weekend. Let's go Bucks.